Today, it's just myself, Miss Booker, and we have Alexander here to check answers. Mrs. Bond is occupied today. She's helping interview our new principal. Vice principal, sorry. One of our new vice principals. Up on the screen, you should have your Do Now today. It's an exit ticket review of 2 problems from our second exit ticket from last week. Okay, I'm going to scroll down so that you can see all of the second one. Oh, okay. So in the first one, it says this work does not show the correct answer, but there are lots of great math thinking in the work. Number 1 asks you, what great math thinking can you identify in this person's work? Try to list all possible examples. And then number 2, what math thinking needs to be checked?
All right, Arden, you are unmuted. Are you going to answer the question? Wait, unmute here. Are you going to answer the question, what math thinking needs to be checked, or what great math thinking can
What great math thinking. So one great math thinking I can notice is that the person multiplied the base times the height of the triangle and then divided by 2.
All right, I'm muting you again, Arden. So Ms. Booker, we have area of a triangle identified. Do you want them to look now at what math thinking needs to be checked?
Yeah, let's have a volunteer tell us what needs to be checked.
Great, that was great, Arden, thank you. I'm looking now for more hands for that number 2. What needs to be checked? From Ozzy. Ozzy, I'm gonna unmute you, hon, okay? Here we go. You're unmuted.
So what they did wrong is they didn't take away 3 from the base length, and so then they multiplied 5 by 8 instead of just 5 by 5.
And a lot of people said that in the chat, Booker. They were noticing that 5 by 8 versus 5 by 5.
5 by 5, great. That's really great. So this was from your exit ticket last week, and Mrs. Bond was kind enough to record the answers for the Do Now. So I'm going to go ahead and put that up, and you can go ahead and check against what you were thinking and what you wrote down. So let me pull that up on my screen here. All right. And here we go.
So now that you have finished the Do Now, I know I'm not here with you to work it out, but I'm recording this so that Ms. Booker and Alexander can go through the answers with you during this class. So you've looked at the first 2 questions. This activity is called My Favorite No. So this work does not show the correct answer, but there are lots of great math thinking in the work. So we want to find what positive things we can find. What work do I look at and I'm like, ooh, yes, that's some partial points because they got that math. So thinking about that question, there are a lot of examples that you could have come up with. You could have seen that they know a formula for the area of a rectangle. They did find the triangle area correctly. They even divided with decimals. They added with decimals. They know that the total area is adding. They knew how to find the base and the height of the triangle. There's so much great math thinking that we could have written down for number 1. So hopefully you got a few of those. For number 2, what math thinking needs to be checked? So what's something that you might be like, oh, actually, this isn't quite right. The part that isn't quite right is this rectangle. And this question is from your exit ticket, and many people did this. So it's a very common mistake, which is why I put it on the board. So 5 times 8 is not the area of the rectangle. Why is that? If you're looking at 8, 8 represents this whole length. So if I were to take that entire length and multiply it with 5, you're actually going to get this area. Because this is where it overlaps. You could use that to solve, but you have to recognize that that is the entire area of a bigger rectangle, not rectangle A. So I want to find the area of rectangle A, which is just this rectangle. To do that, I need to find what this length is. It's not 8, but I need to use 8 to find it. We know that the whole side is 8. And we also know this piece. So if I think of this little piece, I'll outline it in red. I could use that little piece, drag it down here, and that matches up. So this little piece is 3. 3 plus something has to equal 8. So this side is actually 5. So when we're checking our work, the math that needs to be checked is the rectangle, the length is actually 5 inches. If you got to the bonus question, this was also on your exit ticket. For your bonus question, most likely you split it into triangle A and rectangle B. So for triangle A, if you didn't do this, make sure you're writing it down because you could fix your exit ticket from last week. Triangle A has a base here that matches this. So that base is 20. The height we don't know. So it's similar to the last question. This part is 10. So that means this part is also 10. Matching side length of the rectangle. So 10 plus something equals 20, so this will also be 10. So you get 20 times 10. And then remember, if you don't divide by 2, you're actually finding this rectangle, which is not what we want. We want to find the triangle. So you have to divide by 2 to get 100. Rectangle B is 20 times 10, just 200. It's a rectangle, so we do not have to divide that. We add these together to get 300 centimeters squared.
Oop, sorry about that.
Now we're going to move on to our notes.
Okay, there we go. So we had Mrs. Bond helping us out there.
And I'll say, Booker, that Mila, Ravenna, Ruben, Ji Young, and Jessica all had that bonus question answer there. I think it's a really nice job. The only mistake, I think, the most common was not including the units, putting those centimeters squared versus just centimeters versus no units. So really nice job. A couple of you even remembered to put that centimeter squared.
That's great. All right, we're moving on to our notes. Our notes today are a little bit long because we're going to use them to identify three-dimensional shapes using descriptions and nets. We'll start using nets a lot next week, but today we're just identifying different three-dimensional shapes. So right now you want to make sure underneath your do now, right, draw a line, and then you want to title your notes. Today we have Intro to 3D Shapes, and I will bring up the video of Mrs. Bond writing the notes.
Yes, Jackie, you should be writing as
Moving
Miss.
on to our notes. Our notes are focused a lot on vocabulary today, and there will be some drawings of 3D shapes that hopefully we'll be able to do together. I will try to move as slow as I can, but if needed, Ms. Booker or Alexander will pause and rewind so you can redraw those shapes, because I know this is all new. So below your do now, write notes, geometry, which you can shorten to geo, day 5, intro to 3D shapes. So when we look at 3D shapes, we have a lot of vocabulary that goes with them. The first one is called a face. So a face on a 3D shape is the flat surface on a 3D object. So it would be smooth, you could run your hand over it, and it would be nice and flat. An edge is exactly what you would think of when you look at a box and you feel the edge. It's where two faces meet on a line. So where two faces meet. So you would kind of feel the edge. It would be kind of sharp, but it's a line. The vertex of a shape is where several edges meet. You can also call them corners. So the math word is vertex, but in a normal real life situation, you would just call it the corner of the box, corner of the pyramid. So we have these vocabulary words. We can pause the video here to make sure you have that written down. And then when you're good to go, we're going to draw a rectangular prism. I'll talk about what that word means in a moment. So pause the video if you need time to catch up. I know that was more writing than normal, but we're starting our 3D geometry, so there's going to be a lot of vocabulary words.
Okay, the video is paused to give you a moment to finish copying everything down. When you're done, you can give a thumbs up so I know people are ready. Hey. Sorry about that.
We got a lot of thumbs up already, Booker. Some kids showing off their dance moves while they're waiting. A lot of smiles, that's sweet. And then a lot of thumbs up from people whose videos aren't showing. We're maybe at 25% thumbs I've seen so far.
Got a lot of thumbs.
Yeah,
All right, I will go ahead and continue the video then.
here we go. I think we're good.
When we draw a rectangular prism, there are multiple ways to draw them. I like to draw a rectangle. Then when you look at your rectangle, you have these 3 corners that you're going to draw diagonal lines out of, and then connect them. So one more time. You can draw a rectangle. Look at this top 3 corners. I'm going to draw matching diagonal lines, connect it on top, connect it on the side. roughly a box. So using those vocabulary words, your edge is like one of these lines. So this, if you shade it in really dark, make it bigger than all the other ones, that is an edge. A vertex is your corner. So I'm just going to pick the corner, make it really big so you can see that is the vertex. A face is the flat part. So I'm just going to choose the top. So color in the top, that whole thing is the face. So that's how you see all of those vocabulary words on a shape. We are not only going to focus on boxes, we are also going to focus on pyramids as well. So we have to know the difference between prisms and pyramids. So this box is also called a rectangular prism. So when we talk about geometry, there's a lot of vocabulary words that go with them so that we can identify each shape specifically. So with prisms, prisms have two bases. These bases are identical and parallel to each other. Prisms are named by the shape of their base. I'll draw a line here so that we have prisms and pyramids. Pyramids, on the other hand, have one base. All other bases are triangles, and they are also named by the shape of their base. So let's look at a few of these. Now
Okay, let me go ahead and pause that there because that was a lot to write down. So I'll give you a moment to catch up.
Yeah, I still see
You're
you.
done. Oh, nice job, Ozzy. Yeah, go ahead and give us a thumbs up when you're done, and then we'll move on.
Yeah, and the only note I put in the chat there was just making sure you all understand that Bond was just labeling one example of a face, edge, and vertex, but there's lots of them all over that figure if you were to look at all the different parts of that figure. So just keep that in mind. I'm seeing not many pencils moving anymore, Booker, and some thumbs going up. I think we're good. And thank you to the student that asked us to pause. That's what helped us know.
Yeah. All right, I'm going to go ahead and push play again so we can listen to Mrs. Bond some more.
This is where we're going to have to draw things that normally I would print out because it's really hard to draw 3D shapes on your paper. So if you need to pause the video here, pause it here so that everyone can catch up, and then you'll give thumbs up for us to move on.
Look at Mrs. Bond. She knew.
So-
How did she know?
So a rectangular prism, there's another way that you can draw it. Your rectangular prism is your box. So you have a face here. You could draw an identical box behind it and connect all four corners, and that's a rectangular prism. You could have also drawn it the other way, where you draw a rectangle, 3 diagonal lines, connect it on top, connect it on the side. Those are both rectangular prisms. One of them you can really see all 6 sides. The other one you have to kind of imagine that there's the other 6 sides, or the other 3 sides that you can't see. We also have a triangular prism. When I draw these, I like to think of a cake slice. So a triangular prism is called triangular prism because of its base. So the base is shaped like a triangle, so I'm going to start by drawing a triangle. And I have to kind of draw it angled to show all the sides. So then there's going to be all of these sides, and the bottom is also a triangle. So you'll notice that you have a top triangle and a bottom triangle with 3 sides connecting it. So you think of that triangle and then it goes all the way up. If you can't draw that exactly, it's okay. You just have to know that there are triangle bases between. And there's 2 triangles there. For pyramids you're probably more familiar with. So a square pyramid has a square on the bottom. I'm going to draw it kind of like a rhombus so that you can see all the sides. It is a square. And then they're all going to meet up at the top. So I'll put the top over here. And then you have 4 triangles around the outside. A triangular pyramid has a triangle on the bottom. Then there's 1, 2, 3 triangles around the edge. So there's 1, 2, 3, 4 triangles total in a triangular pyramid. So try to draw this as best you can. If you aren't able to draw them exactly, you can always look back at these notes so that you can see what they should look like. And they might not look exactly the same as this. You could have different shaped triangles here, for example. This sometimes looks more like a tent.
All right, I went ahead and paused. And just know, like Mrs. Bond keeps saying, it's okay if your drawing isn't perfect. Usually our practice for this, it'll have the shape and you'll see it. And you just have to identify it. So take a moment to write those down as best you can, and we'll keep it paused for you till I see a lot of thumbs up.
Also, if you just want to practice drawing one at a time, start with the rectangular prism. If you can get that one down, it probably is going to be a little easier when you try the harder ones, like the triangular prism.
And like I was saying, our practice is typically pictures of the shapes. We're not expecting you to draw them, but you'll see something like on the screen where you have pictures of the different shapes, and your job is to identify, right? So we have 6 practice problems here, and our job is to identify the solid figures. We have multiple choice answers, so you can choose which one best fits the picture. And on the screen, we have 6 problems. So you want to go ahead and use your notes to help you identify each shape